Vera Rubin is operational. A star turned directly into a black hole. New images of Uranus from Webb. And in Space Bites Plus, scanning K2-18b for signals from intelligent civilizations. All this and more in this week's Space Bites. People are always asking me when Vera Rubin is going to go live. Well, it went live.
It's alive. It's alive. It's alive!
So on February 24th, it began its full-time operations, taking images of the sky every 40 seconds, moving on to the next spot in the sky, and just continuing to do that. And it will do so for the next 10 years. And every time it returns back to the same spot, it now has this sort of template reference information. And so if there's anything new in that image, then the powerful computers working with Vera Rubin will turn that up and make that available to astronomers. And on the first night, February 24th, they issued 800,000 alerts. And you're talking about supernova, active galactic nuclei, various transient events, comets, asteroids, all kinds of stuff. But this is just the beginning. Once this system is fully operational, once they have added a lot more of the software they're planning, more reference images, they're hoping to get to 7 million alerts every single night. And this is a fire hose of data. And because they're looking to turn this information around within about 2 minutes, so Vera Rubin takes an image, discovers a bunch of things that are new in that reference image, and then provides an alert that astronomers can go and do follow-on observations and try to figure out what that is. And this is really important. When you've got supernova that are going off, you want to be able to make your observations moments after they happen. So Vera Rubin has teamed up with 7 different data brokers who are going to make this information available to various astronomers and observatories around the world. But these data feeds will also be made public. And so you and me, we can go in and watch these feeds for new interesting things that are happening, make discoveries of new supernova, and be sort of part of this experience as all of this new data are being dumped out onto the internet. And so here we are now in the era of Vera Rubin. And so I will have to record 800,000 Space Bites episodes every night for all the new things that we discover. We'll see. Now, if you want more background information on how Vera Rubin operates and sort of the technologies involved, I did an interview with the program director, Dr. Edward Ajhar, here on the channel, and we just sort of cover every part of this telescope. I've also got some other interviews coming up where I'm going to be interviewing people handling the pipeline, the data pipeline. And so stay tuned. We got full court press coverage of Vera Rubin now that we are finally operational. There is a theory that a certain class of stars, when they die, instead of forming a supernova, they will just turn directly into a black hole. The way the theory goes is that you have a massive star, something with tens of times the mass of the sun. It's fusing through heavier and heavier elements in its core. It reaches iron, which doesn't put out any energy when it fuses. And so this causes the star to collapse in on itself. As it does, as the star is starting to compact down, it produces neutrinos, and the neutrinos create this blast wave that moves through the star. And depending on the strength of this blast wave, it can decide whether or not the star is going to explode as a supernova or it's just going to quietly collapse into a black hole. And this is a really tricky observation to make, to catch one of these things in the act. Think about it. You've got to image an entire galaxy and then notice that one star in potentially 100 billion has gone missing. Right? That's tricky. So astronomers think they've done exactly that. They did this by looking through archival data of NASA's NEOWISE spacecraft, which was gathering infrared images, doing surveys for decades. And specifically, they were imaging a galaxy from 2009 to 2022. In 2014, astronomers noticed that a star was getting brighter in the infrared, and they took images of the region every 6 months from 2009 all the way to 2022. But by 2022, it had essentially disappeared. And astronomers did follow-on observations with the Hubble Space Telescope. It was missing in the visible spectrum, and there was a faint source in the near infrared. And so the astronomers think that they were actually watching one of these stars implode, not detonate as a supernova, just disappear into a black hole. There's a term that I like that people are calling this an unnova, which I think is sort of perfect. You get a supernova, you get an unnova. So this is the first example. But when you think about the previous conversation about Vera Rubin, imagine Vera Rubin's going to take images of galaxies, might notice stars that are disappearing, and that could give us a sense of more of these direct collapse black holes. We've got a story about this on Universe Today from Evan Goff, and it's like a really interesting kind of piece of detective work to figure out exactly what was going on in this galaxy. And speaking of galaxies, when you think about your standard traditional galaxy like the Milky Way, you've got all of the stars, but you also got all of the planets, all of the moons, all of the comets, all of the Kuiper belts. You've got all of the gas and dust that fills the galaxy. You've got the halo of hot gas surrounding it. And of course, you've got the dark matter that actually comprises the most of the mass in a galaxy. But galaxies come in various amounts of regular matter to dark matter percentages. And in some very extreme places, astronomers have found galaxies that have almost entirely dark matter and very little regular matter. These are very hard to find. Like imagine, how do you find a galaxy that is essentially has no visible matter in it? So there's a couple of clues. And so astronomers went looking for groups of globular clusters. The globular clusters, these are these sort of compact balls of stars that orbit around galaxies like the Milky Way. We have dozens of them around the Milky Way. They're some of my favorite objects to look at in a small telescope. And their source is not entirely known, but it's thought to be that these are the cores of dwarf galaxies. All of the other material was stripped away from them, and you're left with this kind of this compact core of stars. And so dark matter galaxies should still do this same thing. They should be finding dwarf galaxies, stripping away their stars, and putting them into orbit around them. And so astronomers found a galaxy that appears to have a group of globular clusters that are orbiting around nothing. And not nothing, that when they did follow-on observations with powerful telescopes, they were able to find that there is a faint glow of stars coming from this region. You're not getting the big bright stars that we have in galaxies like the Milky Way or Andromeda, but you're still getting some glow of presumably small red dwarf stars in the area. And that these globular clusters account for about 16% of the brightness coming from this galaxy, which is a ludicrous percentage compared to things like the Milky Way. And so now we've got kind of another tool to be able to find these dark galaxies. Look for clusters of globular clusters floating in space, and you might have a dark matter galaxy that they're going around. We've got a story about this from Evan Goff. And now we've got some new images from James Webb of your favorite planet, Uranus. And this is very cool. So astronomers used Webb to capture one complete rotation of Uranus. And when you think about Uranus, right, it is flipped over onto its side and rotates almost like it's like rolling around the solar system. And it's known to have a magnetic field in the same way that Jupiter does, in the same way that the Earth does. And so in these images, they were able to catalog a full rotation of Uranus, but also be able to track essentially the atmosphere in 3 dimensions, to be able to see higher and lower altitude clouds going around the planet. And they were able to track auroras in the atmosphere of Uranus. And so I always love when James Webb is used to target objects that are inside the solar system. It's not just deep space, it can be used here in the solar system. The solar system is surrounded by a bubble. I'm not talking about all those AI data centers that everyone's planning to launch. And that bubble is caused by the solar wind coming off of the sun. You've got the solar wind coming from around the equator of the sun. You've got solar wind coming from the poles of the sun. And together, these push out the interstellar medium, essentially the combined solar winds of all the other stars, and create this giant bubble. And the Voyager spacecraft recently passed from the bubble that surrounds the sun into the interstellar medium. And so now, whenever they say that the Voyagers have left the solar system, they've actually, they're still in the solar system. It's just that they are no longer in the heliosphere. They've passed through the sort of the turbulent regions that separate the heliosphere from the interstellar medium. And so it's assumed that there would be these kinds of bubbles around all stars. All stars will likely have stellar winds, and so they will have bubbles, but they're very hard to observe unless they're very powerful. And so astronomers have used the Chandra X-ray Observatory to observe a bubble around a young star. It's very young, but it recently became a main sequence star. And through Chandra, they're able to see 2 sources of X-rays. One is the X-rays coming from the star itself. Essentially, the corona around the star is very high temperature. That produces X-rays, and so you get this point source where the star is. But then you get this bubble from the solar wind, stellar wind, that is coming out of the star and interacting with its local interstellar medium. And this heats up the gas around it, and you get this low-level activity across this big, large volume of space coming from the solar winds interacting with the interstellar medium. But this star has solar winds that probably go about 3 times as fast as the sun's solar winds, and they're about 25 times as dense. And so you end up with this bubble around this star. And, because this star is a mean sequence star, it's very sun-like, but it is very young. Perhaps this is what the sun looked like early on in its history. And we've got a story about this from Evan Goff. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that Titan has been bullying other moons in the Saturnian system. So thank everyone who voted last week. We're going to put the vote for this week's episode into the post tab here on our YouTube channel. So when you see the vote show up on your homepage, vote. And if you don't see the votes, well, then you should make sure you're subscribed. Make sure that you click on the notifications bell, and then you can go into the post tab and then vote for a bunch of past polls, and then that will train the algorithm to show this. Now, I've been telling you that you can press the like button, and some of you still have not seen whatever is the strange animation that YouTube shows. Apparently there's like 20 different kinds of animations that YouTube will show you, but perhaps it's just not showing them to you. And so you're just going to have to try one more time to press the like button if you like this video. Or maybe this is not true and I'm just making this up. So you remember in January, NASA decided to bring a crew of astronauts back from the International Space Station, and they were very vague. There was some kind of medical issue, and they decided that they were going to bring the astronauts back home. We didn't know what the issue was, and we didn't know who the issue was with. Well, at least we got one piece of information. We got a statement from the astronaut, Mike Finke, this week, thanking NASA for their attention in whatever his medical issue was, and has said that he's having lots of good follow-up support and things are going great. We don't know what the medical issue was, and that's fine. I think the astronauts get their privacy. But now we're on to the next launch, of course, and this is the Artemis 2 mission. And it was supposed to launch in early February, but we had some delays, which pushed the launch back. It was supposed to be in March. And now, after the most recent wet dress rehearsal, it looks like they're going to be pushing the launch back to April. And of course, we completed last week's Space Bites episode. I said that they were going to complete the wet dress rehearsal and then still on track for a March launch. But moments after we released the episode, we got the news that the wet dress rehearsal didn't go so well. So what happened was they were pumping liquid helium into the rocket. This is used to keep the engines at its optimal temperature and to pressurize the liquid hydrogen and liquid oxygen tanks. This is a very common thing in rockets that they use helium. There was the explosion of the SpaceX rocket a couple of years ago. I toured when I was at the Kennedy Space Center, we went past the SpaceX rocket that detonated because of a problem with the helium system. And it was crazy. Did I take pictures? Anyway, this system was working during the previous wet dress rehearsal, but on the one that they did on February 19th, they ran into some issues. And apparently, whatever the problem is, it is serious enough that NASA's decided they're going to take Artemis 2, take the Space Launch System, roll it back to the vehicle assembly building, and then have to do the repairs in the VAB. Once that's done, they'll roll it back out, but this is going to take a while. We're not going to see them launch in March. We're going to have to wait for that April window for it to show up. And, if you're disappointed, I feel like I warned you. NASA is going to be incredibly careful about this. So although they could launch as early as February 6th, I would be prepared for them scrubbing launches, putting in delays if anything causes them any concern. So we'll wait for the fixes to be made, for them to roll back out to the launch pad, and we'll find out when the next launch window will open up. We've got a story about this from Matt Williams. And speaking of the Artemis program, we had a pretty big announcement on Friday morning by NASA Chief Jared Isaacman that they're going to restructure the Artemis plans for the moon landing. Before, Artemis 3 was going to be the mission that would bring the astronauts down to the surface of the moon. It's going to use a SpaceX Starship as the human landing system that would carry them to the surface of the moon. And Isaacman announced today, on Friday, that they're going to restructure things, that Artemis 3 is actually going to be a test in Earth orbit. They're going to do a docking test with whatever lunar landers are available at the time. So if the SpaceX Starship is ready to go, they'll test with that. If the Blue Origin lander is ready to go, they'll test with that. And then they will then have Artemis 4 be the first landing with humans on the surface of the moon. And they're still anticipating that's going to happen in 2028. So we're going to see this orbital docking attempt in 2027, and then we're going to see a landing on the moon in 2028. And one of the other things that Isaacman said was that they want to sort of speed up the launch cadence of the Artemis missions, that if you're sort of delaying 3 days for these launches to happen, then you're going to have a lot of key personnel that are shifting out. And so they want to sort of speed up and operate more quickly. So this is sort of breaking news, and we'll see how this all plays out. We know of thousands of exoplanets, but we still have no confirmed exomoons. There are hundreds of moons here in the solar system, and so it's almost inevitable that we will find moons in other star systems. But, we can't just assume them, we have to find them. And there have been many astronomers that have searched for moons in other systems, and it is a very tricky problem. It's hard enough to find planets, but trying to find the influence of a moon orbiting a planet, orbiting a star, that is next level. But astronomers who are designing the capabilities of the Habitable Worlds Observatory think that that telescope, when it comes online, should be capable of detecting exomoons orbiting around Jupiter-like exoplanets at about the distance from the Earth to the sun, so 1 astronomical unit. And so what'll happen is that they will measure the light coming from the planet. And of course, because the moon is going to be orbiting around the planet, the moon is going to go behind the planet and change the light and change the reflection of the sunlight coming from the star. And according to the researchers, the Habitable Worlds Observatory should be sensitive enough to pick out that Earth-sized exomoon orbiting around a Jupiter-like planet at that 1 Earth distance, as long as the star is within 39 light years of Earth. So another great goal for the Habitable Worlds Observatory. I've got a story about this from Lawrence Tugnetti. Now I've got a bunch of cool images to show you. First up, this is an image of the galaxy NGC 1637. And this main picture was taken by the Hubble Space Telescope. There's one star in specific that you want to look at. In 2025, astronomers using an automated survey detected the presence of a supernova going off in this galaxy. And then they looked through archival data from James Webb and realized that it had imaged the exact same galaxy fairly recently. They were able to look at the precise spot where the supernova went off, and they were able to find the red giant progenitor star that was there before the supernova. And this is amazing. This has only been seen, I think, one time before, where you see the star and then you see when it explodes as a supernova. And one of the big questions is, what does a red giant star look like moments before it detonates as a supernova? Think about Betelgeuse, right? Come on, Betelgeuse, explode already. Well, we need to know what we're looking at, know when it's going to explode. Next up, we've got an image of the Jellyfish galaxy ESO 137001. And Jellyfish galaxies have been seen across the universe. They have this very strange feature where it's like a spiral galaxy, but then there are these streamers that are coming off from the galaxy. And what's happening is you've got this galaxy that is falling through a galaxy cluster. It's hitting regions of higher density, and they are causing such punching holes in the galaxy, causing these streamers to trail behind. And it's believed that this is a more modern thing that you would see in the universe. But now astronomers have found a much older version, one that's seen about 5 billion years after the Big Bang, or about 8.5 billion years ago. It shows that once again, the universe was able to develop fairly complicated interactions earlier on than astronomers had anticipated. And finally, this is the exposed Cranium Nebula. And it's such a cool picture. And what you're looking at here is a type of planetary nebula. This one's about 5,000 light years away. And we've known about it for a while, and there have been images from the Hubble Space Telescope and the Spitzer Space Telescope, and they haven't been great. And then we got this image from James Webb, and it is unbelievable. One of the best pictures that I have seen this year, by far. You're seeing this star that was once like the sun. And as it reached the end of its life, turned into a red giant, it started to puff out its outer layers into space. It was also releasing a lot of other molecules and chemicals into space. And so this outer shell, this sort of light blue shell, that's the hydrogen shell that is expanding away from the star. And then you got this more chaotic inner region that is other chemicals that were put off by the star. And it will eventually settle back down and become a white dwarf star. But it's just such a beautiful picture. And you've got two versions of it from James Webb. One is from the NIRCam instrument and the other is from the MIRI instrument, and just showing the different wavelengths that they're able to pick up. Different features are resolved in the images. Now, if you want to learn about the science behind all of these cool pictures, we've got individual links to all of them, and Evan Goff wrote all of these stories. I hope you're enjoying this episode of Space Bites here on YouTube. Of course, YouTube is not our favorite place to be able to show our content. We like a place where you don't have to watch any ads. And of course, that is over on Patreon. And so to encourage you to go and watch our episodes over on Patreon, remember, this is completely free. There's no ads. We don't put it behind a paywall. You don't have to donate. You can just watch it. We put one extra story. And this week's story is pretty cool, which is that, you remember the Haitian world K218b? Haitian. Ocean, Haitian. Yeah, I said it right. Okay. Remember the Haitian world K2? It's Haitian. Ocean, Haitian. Now I'm all confused. Ocean, Haitian. Okay. Remember the Haitian world K218b? Well, astronomers have recently scanned it with two of the most powerful radio telescopes on Earth to detect any advanced civilizations sending signals at us. Did they find anything? You're going to have to watch the episode. I'll put a link in the show notes. But if you want even more space news, we are covering so many more stories over on Universe Today, like 30 to 40 stories every single week. And if that feels like it's hard to stay on top of, don't worry. I write a weekly email newsletter that I send out to 70,000 of my closest friends. It contains short descriptions of each one of the stories on the website, cool pictures, and I write every single word myself. There's no ads in it. It's completely free. You can sign up, go to universetoday.com/newsletter. I did an interview with one of my patrons today, and she reminded me of something that we just started doing that I probably haven't told you about. And I'll talk about that in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Biela, Cooper and Ellie, Darkfinger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Parlbuck, Rinkaidu, Richard Williams, Sean Sargent, Stephen Filer Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I was interviewing my patron today, which is a thing that I do. When you join our Patreon, I will send you an email that will say, hey, do you want to have a conversation with me? And then you will set up a time, a calendar, and you will talk to me. It's actually me. This isn't AI. This isn't fake. This is really me. Yes, this is the thing I do. I have interviewed 1,200 patrons so far. But she was saying that she heard my original call for joining our Patreon about a year ago. But because we were doing billing by the month, that was not interesting to her. But a couple of months ago, we decided to flick the switch on Patreon where you can do it at a year at a time, and there's like a discount. You get a month free. And so she said that was exactly what she was waiting for, and she was able to become a patron for the entire year with just like one purchase on her credit card. So if you have been holding off becoming a patron of us just because you don't want to do the monthly, you want to just do a year in advance, get a bit of a discount, go to patreon.com/universe today and you can do the same. And of course, you can do an interview with me. Wouldn't that be fun? All right, we'll see you next week.